Hello everyone, welcome to this video for algorithms and constructs, and we're going to be talking about stacks and queues. So what I'm going to do is, just to make it a little bit more manageable, I'm going to split this into two videos. One of them is going to be on stacks, and that's this one, and there is another video that is going to be about queues. So without further ado, let's get to it. So we're going to start with the stacks. So stacks is a type of collection, and when we say collection, it's going to be a group of objects that is designed to contain other objects. Now, we've done something similar to that before, so you probably are familiar already with arrays, you probably are already familiar with array lists and other type of collections, and stacks is just another collection. Now, what is special about them? The important thing about the stacks is that they follow an important rule called last in, first out. So to give you an example of this, let's think, for example, of a stack of books. So if I put one book in the stack, and then I put another book on the stack, and then another book, and then another book, I won't have access to the books that are below. I will only have access to the last one that came into the stack. So if I want to remove somebody, the first one that is going to be out is the last one that came in. So that is the idea of a stack. And normally we can visualize a stack in a vertical way. So let's take a look at this, for example. So if I have a stack of elements, I will pop that element by removing the top element on the stack, and I will push an element by adding an element on the stack. Something that is important to keep an eye is that I don't only have access to whatever element I have at the top. For example, in this case, when I'm popping the element, I only have access to pop the first element on the stack. And if I'm pushing an element, I can only push it at the top of the stack. So I cannot really do anything with elements that are down below the stack. Now, this very same principle applies to computer data structures, and the stack is one of those structures that are very important. We'll see a little bit of a few examples in a second, but I want to mention before, what are the methods that any stack would have? So there is 5 methods that are like the basics of any stack. And the first one would be push, which is when I'm adding somebody or an element on top of the stack. The second one would be pop, which will remove an element from the top of the stack. Then we have pick, which tells me what is the element at the top of the stack, but doesn't remove it. And then I have 2 other methods that has to do with the number of elements on the stack. So if it is empty, it's a method that will return a boolean, true or false, if the stack is empty. And size is a method that will tell me how many elements I have on the stack. Now, I have a little bit of an example in here, and if you have the chance to have a look at that on your own time, I'm not going to do the whole thing, but I mention a few of them. So suppose I have a stack that initially is empty, and I push the value 5. Now I have indicated in here that the bottom of the stack is going to be the left, and the top of the stack is going to be the right. So if I push an element 5, so that is going to go into the stack, and that is the content of the stack. There is only one element. So if I push 3, I can push to the top of the stack the number 3, and now 5 is lower below. If I request the size of the stack, it will tell me the stack has 2 elements. If I pop an element from the stack, it will return the value 3, which is the one that is at the top, and now my stack only contains the value 5 because 3 has been popped, has been removed. Now if I call the method is empty, it will tell me that that is false because there is a value in there. But if I pop that value, it will return the value 5, and now it is empty. So if I call the isEmpty method, it will say true. Now have a look at the rest of the example, just to make sure that you understand what pop, push, pick, is empty, and size mean. Those are the five methods, or the five basic methods of any stack. Now, I can nearly hear you asking, well, Amilcar, what does this have to do with computer science and programming? Why are we saying this, and why? What do we use this for? Well, there's many applications for this, but the most typical application of this would be your undo sequence on Microsoft Word, or in any program that you have an undo section. So every time you do changes, those changes get piled in a stack. And when you do undo, what you're doing is removing elements from the pile of the stack. So that is a typical example of where computer scientists use stacks for a particular application. Another example, for example, would be your back button on your web browser. Every time you open a new web page on your web browser, that gets on the stack. And if you go to another page, it goes to a stack. And if you go to another page, go to a stack. And if you go to another page, it goes to a stack. Whenever you start pressing the back button, what you're doing is removing to the previous and the previous and the previous. What you're doing is going down the stack. Now, how do we use stacks in Java? So there is a stack that is built into Java, and we can use it straight away, which is the one that you can see on the screens. We can say stack strings my stack equals a new stack. And we can use this not only with strings, but with any type of data. So we can use objects for that, we can use strings, we can use integers, we can use whatever we want. So I'm going to do this on Eclipse just to show you how this works. So I have a brand new Eclipse project. There is nothing really in it. It's only a main method, a main class with a main method. And there I'm going to use my stack. So I'm going to say stack my stack. I need to define what is the type of the stack. So let's say, for example, string is equals to a new stack of a string. Of course, the first thing that it's going to tell me is that I'm missing the import. So I just bring the import into the class, and there it is. My stack is ready to be used. So let's see. Let's try to use it. Let's say, for example, I want to add elements to the stack. So all I need to do is say my stack.push, and I can push any value I want. For example, Amilcar. Now, again, this is a stack of strings, so I need to put text in there, but it could be a stack of anything. Now, to see how these work, I'm just going to use a system that out of println to print the stack. So, as I said, this is just a new stack, and I just push one value, the value Amilcar, and I'm going to print it to see what I get. And there it is. My stack has only one value, Amilcar. Now I can add another couple of values just for the sake of practicing this. I'm going to add, let's say, Amilcar, Mark, say Carol, let's say Kathleen, let's say Graham, and I'll print the stack and let's see what happens. So as you can see, all the elements in the stack have been added one after the other. The one at the very top at this moment is Graham, and the one at the very bottom is Amilcar. Now, you would ask now, well, Amilcar, what's the difference between this and an array list? Well, in an array list, I can add elements, but then I can loop them or I can remove them using the index. In this case, I don't have indexes. I only have access to the top element of the stack. So for example, if I do my stack dot pop, notice that in this case I'm removing I'm going to remove the top element from the stack, but I can't access any of the other elements. So let's see this in action. So I'm just going to print the stack again and run this. So there it is. The first time I print the stack, Gram is in there, but at the moment I say pop, the top element, which is Gram, gets removed, and now my stack doesn't have that element. So I can do pop consecutively. I can say, for example, my stack the pop again, and print the stack again. See what we get. And I can see that every time I call the method pop, it's going to remove whoever element is at the top of the stack. Give it a go and have a look at what other methods you have in that stack. You can say my stack dot and see what other elements you have in there, and see if you can use any of the other elements in that particular implementation. Brilliant. Now, that is the easy one. That is a stack that is built into Java. But it's never that easy with me, is it? What I want to do now is I want to write our own stack. And what we're going to do is we're going to write a stack that is what is called an array-based stack. What does that mean? Well, my array-based stack is going to have all the methods that a regular stack has, but in the background, as an underlying structure, is going to have an array. And then we have to create the logic to put all the elements in the array according to the rules of a stack, and keep track on who is my top element in the array. Now, for this, I'm going to give you an interface. Now, an interface, I have a little bit of a reminder in there. An interface is a set of methods that a class must have. Now, I'll show you in a second how to use that. But I would invite you to pause this video for 5 to 10 minutes and try to give this a go. Create a class that you're going to call my own stack, implement the interface that I'm giving you in the pre-class code, and try to write your own stack based on an array. So make sure that you need to keep track of all your data, your array, and probably where the top element is. So give it a go, and then we'll do it together. Okay, let's take a look at this. So this is the code that I have given you today, which is an interface called array stack. And I can see that the interface array stack has 5 methods in there. Now, it's not coincidence that these are the 5 methods that we discussed at the start of the class. So I have a method called push, that it will put an element on the top of the stack. I have a method pop that will remove the element from the stack, and so on. This is exactly the same thing that we did before, or that we discussed before. So what I want to do is I want to code this. I want you to do this with me. So I'm going to create a new class, and this new class is going to be called my own stack. Again, we can use the stack that is already built into Java, but as I said, we're trying to now understand how that stack has been coded, how they work in the background. So this new class, my own stack, is going to implement the array stack interface. Now, if you have any questions in this one, you can ask me during the live class, but remember, an interface is a set of methods that has to be implemented, and at the moment I say my class, or in this case my own stack class, implements the interface, I will need to implement the unimplemented methods, and that's actually what Eclipse is telling me here. You need to have those methods coded. Okay, so a couple of things that we need to do before we start coding the methods. So if this is a stack, the stack needs somewhere to store the data. And I already told you that we want to store the data in an array. We could use an array list, that's perfectly fine, but I'm going to use an array for this. So the first thing that this class should have is an array of strings that I'm going to call data. The next thing that this class should have, well, I should keep track on the number of elements that I can actually store. In other words, the capacity of my array. Remember, my array has a fit size. Once I decide the size, I cannot change that. So I'm going to have a variable just to keep track on that, just to make sure that I never go over that size. So I'm going to say private int capacity. The other thing that I'm going to define in here is how many elements I have in the stack. Now, the fact that I have a capacity, for example, for 10 elements doesn't mean that I have 10 elements. I might have 3 or 4 or 7. So the capacity and the size of the stack is not exactly the same. So I'm going to define one private integer that is going to be for the number of elements that I actually have, which is the size. And finally, I need to keep track of which one is my top element. Why? Because that's the only one that I have access to. So I'm going to say private int top. Perfect. Now the other thing that I need to have in my stack is the same way we did for the stack that is built in. I am calling the constructor of a stack. In this case, I need to do the same. I need to have a constructor for the stack. So because this is one that is custom made, that is one that is we're making ourselves. So I'm going to define a couple of things as a design criteria. So my own stack. And one of the things that I'm going to define in here is if you want to create one instance of my custom implementation, you need to tell me what capacity you want. Again, that is just my design criteria. In this stack that has been built in, it has a dynamic size. It probably is using a array list in the background. I don't know how it is written, but because the one that we're writing is with a string, I'm deciding, well, if you want to create a stack, you need to tell me the capacity. So I'm going to say this.capacity is going to be equals to capacity. Perfect. The next thing that I need to do is I need to create the array. Now in this case, the variable for the array has been declared, but the array hasn't been created. So I need to say this.data is going to be equals to a new array of strings of size capacity. So my array of a string is going to hold as many strings as the capacity has defined. Now the size on the top. Let's start with the size. If I'm creating a brand new stack, that stack is empty. That means that I don't have any elements in the stack. So my size at the beginning of the stack is going to be 0. What about the top? Well, the top that's going to be an interesting one because the top is going to be a pointer, and I'm going to do a little drawing for that. Suppose this is my array. So I'm going to draw an array in there. Suppose this is my array and I have a capacity n. It doesn't really matter what is the capacity, but something that I do know is that my first position is 0, the second is 2, is 1, the third is 2, and so on. So my top is going to be an index or a pointer that I'm going to put pointing to the most top element in the queue. So if I add somebody, if I add an element to the stack, I'm going to put it in there. Suppose I put that element in there, and he is my top index. Now, if I add another element, so my top index has to move forward and come to the next element because this is the most top element in the stack. So if I add another element, well, the top index has to move forward and so on. So if I pop an element, if I remove an element from the stack, then the element has to be moved, but also the pointer has to be removed to the previous, that have to be moved back to the previous stage. So it makes sense that if I'm starting the queue or the stack from scratch and my stack is 0, well, it doesn't make sense to have a top pointer at 0. It makes sense that my top pointer is starting in -1, which is one position before the stack has been populated. In that way, whenever I add my first element, my top position is going to move to 0. And if I have another element, my top position is going to move to 1. And if I have another element, my top position is going to move to 2. Brilliant. So having said that, now we can go back to the code and I can define that my top position is going to be -1. Now that I have defined all the attributes that my stack is going to have, and I have defined my initial state of the object stack, now I can start working on the behavior of the stack. Now let's take a look at the methods that I have included in the interface. So let's go one by one and start with the push method. The push method receives as a parameter the new element, and it makes sense because if I want to put an element into the stack, you need to tell me what element that is. So that element will come in the variable new element. But also the method will return a boolean, and that boolean would be whether the pushing operation was actually successful or not. So how do we do that? Well, it makes sense that if my top index is, suppose we have an empty array. If I have an empty array, my top index is going to be -1. So the first thing that I should do is I should increase the value of my top index. So now my index is not -1, but 0, and I can put an element in that position. So I can go and say data, which is my array of data, at position top is going to be equals to the new element. Perfect. We have added the element to the position. We have added the element to the array itself. What will be the next thing? Well, I have a variable that is in charge of keeping track of the number of elements that I have in the stack. So I need to do that as well. So I need to increase the value of size. Lovely. And now if that is done, then I want to return true. Why? Because everything was successful. Now, is there any situation in which this is not successful? Well, yes, this might not be successful if my array is already full, if my size have reached my capacity already. So I need to have a condition that if my size is bigger or equal than my capacity, then I need to say, I'm sorry, this cannot happen. So I return false. So that would be my pushing method for my stack. Let's take a look at the pop method. So the pop method is going to remove the top element from the stack. So the first thing I need to do is I need to save that element, because remember, even though I want to remove it, I also want to return it. So I'm going to save that method in a variable that I'm going to call a string to return, and it's going to be equals to my data at my top position. That's why I have that variable top, because that is keeping me track of where is my top position. So I go and say I save that, and that is the variable that I'm going to return at the end. Undo. That is the variable that I'm going to return at the end of the method. But there is another couple of things that I need to keep an eye on. And one of them is that I need to move the top index down a bit, because if suppose my top element is in the index 6, now I need to bring it back to index 5. So that top element has to reduce in 1. And you guessed it, also my number of elements in that position has to be reduced. So my size is also reducing. But there is something else that I need to do in here, which is I need to actually remove the element from the array. So before I move the top position down, I can go and say data at position top is equals to null. So now that is doing everything that I need to remove the element. I'm saving the element to a variable in order to return it, removing the element from the array, moving down my two counters, my top index, my number of elements, and then I return this. Now, the same thing as the push. Is there any situation in which this might go wrong? Well, yes. If I'm trying to pop an element from a stack that is already empty, I should return a null element. So I'm going to say there, if my size, which is the number of elements that I have, is equals to 0, then I want to say return null, and don't do any of these things. Why? Because this thing only makes sense to be done if I actually have elements to pop from the stack. Good. So not bad. Let's take a look at the next method, which is pick. Now pick should not remove an element. It should return the element that is at the top of the stack, but without removing it. So that should be fairly straightforward. So I should say return my data at position top. And that's it. I don't need to change the size or the top counter because I'm not removing the element at all. But something I need to keep in mind is, again, if I try to look at the peak of the stack, if the stack is empty, then that should return a null element. And that is exactly the same thing as in the pop method. So I'm just saying, if the size is 0, return true. In any other case, return whoever element is at the top. Good. Let's take a look at the size. Again, the size should be fairly straightforward. So return, well, I don't want to return 0 all the time. I just want to return the size of the stack. And that will apply whether the stack is empty or not. It really doesn't make any difference. And what about the isEmpty method? So, well, the ifEmpty method is going to return is going to return true or false depending on whether there are some elements in the stack or not. So if the size is equals to 0, then return true because it is empty. If it's not equals to 0, then return false in any other case. Now there is another method that we should have in here, and I didn't put it in the interface, but it makes sense that if I have a stack, I want to be able to print the stack. So I need to be able to have a look at the stack when I print it to the console. So I'm going to add a method there called toString, public string toString. Now we've talked about that before, but if we don't remember, the toString method is a method that runs automatically every time I put an object inside a system that I have a println. So this is going to return a string that can be displayed to the console. So in this case, I want to display each one of the elements that there is in the array. So I'm just going to define in there, for example, a variable string that is going to be to return, that I'm going to start the little open bracket and space. And now to that string, I'm going to start adding the number of elements that I have in the stack. So for that, I'm going to use a for loop because I have my elements in an array. So I'm going to say for integer I equals 0, I lower than the size of the array, and careful, this is the size, not the capacity, because I want to do this with as many times as elements I have in the stack, not as many as I can hold in the stack, and I++. So finally I can say to return plus equals, and then I can stick in there whoever I have in the data array at the given position I, and I'm just going to add there a little empty space just to print it nice and tidy. And finally, Once I have done that for each element that I have in the stack, I can go and say, I can close the string saying toStrings plus equals, and then I just close the string with a closing bracket, and now I can return that variable to return. Now I have a typo in here. This is to return. There you go. So my variable to return starts with an opening bracket, then it populates all the data, and then it closes with a closing bracket, and then I return that. Now, the only thing that I'm missing to finish this class is to actually test the stack. And to do so, all I need to do is go back to my main method, to my main class. I'm just going to save everything. I'm going to go to my main class, and instead of using the stack that is built into Java, I'm going to use my own stack. My own stack. Perfect. So that's the same one that I'm going to use in here. And I'm just going to define here size 10. I need to get rid of this as well, of course. There it is. So in this case, I have my own stack, my stack, and all the methods that I had in the other stack, the built-in one, are also in here because we add them all. And we also add the toString method, so when we print it runs nicely. So we should be able to save this and run it. And there it is. This is my own implementation of the stack, which is doing exactly the same thing that the built-in is doing. Now, in fairness, in your own jobs, will you write your own stacks? No, you won't. You will be using the stacks that are already built in, but it is important that you know how they work, and that's exactly what we've done in this class. So thank you for listening to this class. I'll see you in the next video, which is going to be about queues. So see you in the next one.